here the question is if different classes have different scores in the language test. So if we look at the variable language test and we look at the classes, we see there's numbers. Each class has a different number. It's kind of like a name of a class, right? So it's like a nominal scale, right? Will be our factor. And we want to know how many levels are in this factor. So we have class 10,003, 10,012, 10,017, 10,019, 10,021. So we already have 5 different classes with 5 different levels on our factor variable. So we have more than 2 groups. We're going to go for an ANOVA. So we're going to analyze, compare means, one-way ANOVA. The class number is our factor. Click that over. And then we're interested in the language test as our dependent variable. And language test, because it's interval level or on the interval scale, we're using, we can use it one-way ANOVA. We can compare means. And right here we're going to hit the options. We're going to ask for descriptives, and we're going to ask for the homogeneity of variance test. See if this checks if the variances are similar across the group, right? If they're not statistically significantly different from each other. And we're also going to ask for a means plot. And hit OK. And now here we have first the descriptives. So for class 10,003, the n is 21, so we have 21 students in this class, and the average, the mean in the language test is 24 for this first class, with a standard deviation of 11 and the standard error of 2.45. Then if you look at the 95% confidence interval, we see that the lower bound is the mean minus 1.96 times the standard error, which is 18, right? 24 minus 2 times 4, 4.5, about 5, 24 minus 5, around 19, yeah? And then the upper bound is 24 plus 1.96 times the standard error, which is around 29. So we know with a 95% confidence that the mean, the true mean is actually somewhere between 19 and 29. We also see that the minimum of the scores in this class was 6 and the maximum was 43.5. This test actually runs from 0 to 50 points, so they're quite close to, they're not that close, nobody at the maximum in this class. Then we see the class 10,012, there were 24 students in this class, an average of 32 with a standard deviation of 7.65. And here we had a minimum of 15 and a maximum of 43.5, and so forth. Then the next one is the test of the homogeneity of variances. This is the same test that we also did for the t-test, right? We wanted to see if the groups had the same variance. And this here is an F ratio, so we see 3.349. And we have degrees of freedom 1 is 5 groups, 1, 2, 3, 4, 5 minus 1 is this 4, and the 97. So 102 minus 5 is the 97. So we have these 2 degrees of freedom, which are statistically significant because it's smaller than 0.05. So what does this tell us? The null hypothesis is that there's no difference in the variances, right? That all these variances are equal across the 5 groups. Now, since we get a significant result, we conclude that there's differences here. So, for example, this class 10,021, has a standard deviation of 6, and in the first class, 10,003, has a standard deviation of 11. So these guys vary much more amongst each other than these guys. right? So that already gives an important piece of information, because it tells you that the variation across the classes varies. Now, ANOVA is a very robust statistical test. So you don't really have to worry too much about violating this assumption. Right? Normally, in order to calculate an ANOVA, we assume that the variances have to be equal. But because it's so robust, in general, you're fine running the ANOVA anyways. Okay? But it is an important piece of information because it tells you that some of these groups are less different within each other than other groups. Now we move on to the ANOVA, and you see that we compare the between group variation, mean squares of 630, with the within group variation, a mean square of 66. Right? So 630 divided by 66 is 9.48. So this is a quite large F ratio, and accordingly it's also significant. Right? The probability is smaller than 0.05. So this tells us that the variation between the groups is much larger than the variation within groups. So there is a significant difference between these classes. Let's look at the graphic overview. Right, we see this class is pretty low here on 24, and this class a little higher, 17 even higher, 19 a little lower again, and then 21 again a bit higher. Now right now we just know that somewhere in there is a difference between these classes. We don't know exactly where. We probably can suspect that this class will be different from this class, right? The lowest from the highest. But then another question is how much these classes here vary from each other, if they're statistically significantly different. And for that reason, I'm going to go back into the comparing the means, one-way ANOVA, and now we're going to ask for the post hoc, and I just ask for the chef value to be conservative, and I hit OK. And we get the same information, but in addition we get the post hoc, and now here we compare this class 10,003 with all the other classes. Right? We see that this class is 8 points lower than class 12, which is statistically significant. Then the 10,003 is 12 points lower than 17, which is statistically significant. And then here it's 9 points lower than 19, which is not statistically significant, right? Or just barely not. Then on 21 with 14 points, again statistically significant. Then here 12 and 3 we repeat, right? We looked at that already. But 12 and 17, not statistically significantly different from each other. 19, not different. 21, not different. And then from 17, we had these already, 17 and 19, not different. 17 and 21, not different. And now the last one we didn't look at is 19 and 21, not different either. So now we can write up our results, and that will be in the next video.